Welcome to your Unit 1 Combinations Notes, 1.1, Counting by Systematic Listing. Please follow along on your own piece of paper. A one-part task is something that you're doing one time. So for example, if we were selecting a club president, we have a club, Club N, and has 5 members in it, Michael, Zeke, Haley, Joseph, and Abby. And how many ways can this group select a club president? Well, I have one spot available. And in that one spot, there are 5 people that can fill it. So there's 5 ways that I can select that president. A two-part task is something that we're doing. You choose one thing and then you choose another. So for example, we've got a couple different things down here. Determine the number of 2-digit numbers that can be written using the numbers from the set 1, 2, and 3. So if I have a 2-digit number, here's my first digit, and here's my second digit. I have 3 numbers. It says nothing about not repeating. It says nothing about what has to go first or what I can't use. So I have 3 options for this first number, and I have 3 options for this second number. So 3 times 3, there are 9 ways that I can create a 2-digit number from this set. Here's another example. Determine the number of different possible results when 2 dice are rolled. Now there's a way to do this, and so we'll go over it right now. What you're going to be doing is you're going to be creating a table. So you have all of your options. Let's say you select 1 die, or this is, you get a 1, a 2, a 3, 4, 5, 6, and if you have your second die, 1, 2, 3, 4, 5, 6. So now we're going to be looking at all the ways that those can go together. And I'm going to move it out of the way. Oop. Okay, so I can roll a 1 and a 1. A 1 and a 2, a 1 and a 3, a 1 and a 4, 1 and 5, 1 and 6, etc. And if I count up all of these different ways, then there would be 36 ways that I can roll 2 dice. Next question, what if we were talking about people and electing officers? So find the number of ways that Club N can elect both a president and a secretary. So I had 5 people in my club, and I'm looking at a president and a secretary. Now, if I choose someone for my president, can they also be my secretary? Not really. When you're doing an elected official or you're talking about people, you can't use the same person twice. Okay? So I have 5 people that can fill this president's spot. I take 1 person away, I have 4 people left. So 5 times 4, there are 20 ways that I can select 2 club officers. What about this one? Selecting committees for a club. Find the number of ways that Club N can appoint a committee of 2 members to represent them at a conference. So for this one, it's the same thing, really, because I have 2 members, right? And once I've chosen someone, I can't choose that person again. So 5 people can go here, 4 people can go here. There are 20 ways. What about using something called a tree diagram? So building numbers from a set of digits, and we're using a tree diagram. So find the number of 3-digit numbers that can be written using the digits from the set 1, 2, and 3. And we're going to assume that repeated digits are not allowed and you cannot repeat your digits. So I have a 3-digit number. Here's my first, second, and third. And it says that I can't repeat any numbers. So if I put a 3 here, I can't also have a 3 here. And this one, it would be kind of tricky to do the multiplication like what we've been doing. So we're going to do something actually called a tree diagram, because this is going to make sure that we follow the rules that they've provided for us. They say that no repeated digits. So repeated digits are allowed, and so we're doing this 2 different ways. So the first way, I have number 1, 2, and 3. And after the 1, I can either have a 1, 2, or 3. And I can have a 1, 2, or 3. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 ways. The same thing is going to happen here. 1, 2, 3. There's going to be 9 ways here. Do the same thing here. Each one of these, 1, 2, 3, 1, 2, 3. I get 9. So 9 plus 9 plus 9. I would have 27 ways, and this is if I'm allowed. Repeats allowed. Let's say repeats are not allowed. So this one, if I were to be multiplying, it would be 3 times 3 times 3. But when you cannot multiply is when you have these not allowed. I mean, you can, but it just gets a little bit tricky, and I want to make sure we can visualize what we're doing. So 1, 2, 3. So after the 1, I can have a 2 or a 3. And after the 2, I could have a 3. After the 3, I could have a 2. So I'm not repeating any digits. I have 123, and I have 132. Here, I can have a 1 or a 3, 3 or a 1. So I have 213 or 231. And last but not least, I have 312 or 321. 1, 2, 3, 4, 5, 6. There are 6 ways. Now we can multiply. I know I said not to, just because I want you to see how this looks visually. But if I had my 3 digits, I have 3 numbers that can go here. I only have 2 numbers that can go here, and I only have 1 number that can go here if I'm not repeating. So 3 times 2 times 1 is 6. So what about attendees at a concert? Again, we're using a tree diagram. This one's going to get a little big. Josh, Kristen, Tucker, and Chloe have tickets for 4 reserved seats in a row at a concert. And how many ways can they seat themselves so that the girls will sit together? And just for simplicity's sake, we're going to change this, her first name, because it gets a little difficult if you have 2 Ks. So we have 4 seats, right? And the girls could sit here. Right? They have to sit together. They could sit here, or they could sit here. Okay? So no matter what, the girls have to sit together. So I have 2 girls that can go here, right? So that make 1 girl here. And the problem with this way is that there's a lot going on here. And it'd be kind of hard to keep track of everything that's going on. So let's expand that into that diagram we were talking about. So I have Kristen, let's say, is in that first seat. Chloe, Josh, or Tucker. So if I have Kristen in that first seat, she has to sit next to Chloe. Chloe can sit next to either Josh or Tucker. If Chloe's in that first seat, then Kristen has to sit next to her, and then she can sit next to either Josh or Tucker. Josh can sit next to either Tucker, Kristen, or Chloe. If Tucker's next, then it can be either Chloe or Kristen, and then Chloe, Kristen. If Kristen's there, Chloe has to be next, which would leave Tucker on the end. If Chloe's here, Kristen is next, which would also leave Tucker on the end. So I have 1 way, 2 ways. There's 2 ways here. I have 2 ways here. Sorry. I have 1, 2, 3, 4 ways here. And let's say Tucker, it could then be Josh, Kristen, Chloe. And then after Josh, it could be Chloe or Kristen, Kristen or Chloe. After Kristen, it would have to be Chloe, and then Josh. After Chloe, it would have to be Kristen, and then Josh as well. 1, 2, 3, 4. 4 ways. I'm not saying you can't multiply here, but it definitely is a little bit easier to visualize when you're using a tree diagram. So 2 plus 2 plus 8. So I would have 12 ways. Okay. Next page. This is just end of our notes, I guess. So please go ahead and do your homework. It should be on your Canvas page. If you have any questions, let me know. Thanks. Have a great day.